So guys, last meeting we started to solve 4 reactions, and we learned that we have 3 types of supports: fixed, hinged, and roller. Fixed has 3 reactions, hinge 2 reactions, and roller 1 reaction. And I told you that if you have something called pin connection, like this one, we have pin connection at F, and we have another pin connection at E. The beam is pin connected at E and F. What does it mean? It means you have to do separation. It means you have to do separation. That means for problem number 4 in the homework, I will separate this part of the beam to how many parts? Any answer? How many parts for this one?
3.
3? Perfect. So, here is the first part, second part, make it smaller. Put your supports. We have support at A and B. A and B. What else? C and D. C and D. What type of supports do you have? At A, we have hinge. B is roller. C is roller. D is roller. So we have 2 reactions at A, XA, YA. We have 1 reaction at B, YB. We have 1 reaction at C, YC. We have 1 reaction at D, YD. What else? At this connection, E, we will have 2 forces, 1 horizontal and 1 vertical. The horizontal one will be called XE, the vertical one YE. Make sure the same reactions YE and XE will be on the other side but in opposite direction. Connection E looks like this. Connection E, it's pin connection. So I'm gonna do separation, and both 2 reactions will be the same 2 reactions on the other side but in opposite direction. The same meaning at F. We have pin connection at F, so I'm gonna put 2 reactions, YF and XF will be the same values. So we have XF and we have YF, same values but in opposite direction. What else? What do you have else? The applied load. We have uniform distributed load, we have concentrated load, all of this stuff. So we need to put distributed load here and 1 concentrated load here. What else? 1 concentrated load here and uniform distributed load here. So we have 3 problems, 3 parts. Part number 1, part number 2, and part number 3. Can you solve it or you cannot? What do you think? Do you remember the problem I covered before? Problem number, example number 4. We have only 2 parts, but in this case, we have 3 parts. That's fine. For the first part, I'm gonna apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Second part, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Third part, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. By the way, for your information, xf equals 0, xf equals 0, xe equals 0, xe equals 0, xa equals 0. We can neglect the horizontal force. We don't have any horizontal force in this problem. So you can start with, I believe you can start with part number 3 or part number 2, and then you can solve for part number 1. It's very easy, nothing. This first step is very important. You have to solve, you have to make separation, you have to draw the free body diagram, put your reactions correctly, and you can solve. Make sure this distributed load will be equivalent to 2 times 12, 24. 2 times 12. This uniform distributed load will be equivalent to 3 times how much? 12. 36. Any question for this point? Any question for this example or this problem? Any question? Okay. Problem number 5. Problem number 5. I'm reading the problem. Guys, you can read the problem carefully. I have 2 points I have to focus on. The first point, we have pin support at A. So A is pin support. D is pin support. And C is pin connection. This connection, C, is pin connection. You don't need to figure out this information from the diagram, from the picture, from the figure, but you have to read your problem carefully. I can figure out what type of supports by reading the problem. We have pin support at A and D. We have B is fixed connection. I don't care. Joint C is pin connection. What does it mean? What is the meaning of pin connection? I have to do separation. So I will do separation here. What else? Nothing else. That means this frame will be divided or will be separated to 2 parts. The first part, this one. The second part, this one. Does that make sense? That makes sense? A is pin support. So we have 2 reactions, one vertical, one horizontal, XA and YA. D is pin support. So we have 2 reactions, one vertical and one horizontal, XD and YD. XC is pin connection. If you assume we have two reactions here, XC, YC, these two reactions will be the same on the other side, but in opposite direction, YC and XC. Don't forget, we have distributed load here. How much the equivalent for this distributed load? The equivalent will be like this. How much? How much? 15 times 6. 15 is the value of the distributed load. 15. 6 is the total length of this load. So we have 90 kilonewton. And we have two concentrated loads at this location and this location, 50 and 40. That's it. We are done. So we have two problems, two parts. The first part, I'm gonna apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Set up your equations and you can find what you can. The second part, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Set up your equations. Probably you have equations here, can be solved with equations here to find your unknowns. You need to set up your equations for the first part, equations for the second part, and finally you can find equation to be solved together to find the unknowns. So if you are looking for reaction, I'm gonna read the problem carefully. The first thing I need to focus, what is the type of support? Hinge or pin or fixed or roller. The second thing I need to focus out, do you have pin connection? Because if you have pin connection, you need to do separation. How many parts based on how many pin connection do you have? For this problem, we have pin connection. So I divided the problem to two parts. For this problem, we have two pin connection. So I divided this problem to three parts. The previous one, we have only one pin connection. So I will divide the problem to two parts only. That makes sense? Any other question for these homeworks? Okay, for example number 7, in the homework, we have a new idea for this problem. Sometimes we have something called link member, or can be called two force member. This member is a special member. If you can find this member in the problem, you are lucky, because the problem becomes easy, more easy. Two force member is a member with two pin connection at the two ends. No external loads applied directly on this member. We have two conditions. We have two pin connection at the two ends of the member. No direct external load on that member. If you go back to this problem, what do you think about member AB? Member AB, we have here pin connection. At B, at A, we have pin connection. So the first condition is good. Two pin connections at the two ends of the member. Unfortunately, member AB, we have external load directly applied to the member. That makes sense? So the second condition is not okay. That means member AB cannot be considered two-force member. So please try another one. Okay, what do you think about member BC? Let's try. Member BC. Do you have pin here? Yes. Do you have pin here? Yes. So member BC has two pin connections at the two ends of the member. The first condition is okay. The second condition, do you have any external load directly applied on this member? Do you have any external load, any concentrated load, any distributed load, any concentrated moment, anything applied directly to this member? No, we don't have. That means the second one is okay also. So I can say this member can be considered two-force member, or can be called link member. That means I am lucky? Yes, I am lucky to find this member. Please make sure the two conditions are okay. Two pin connection at the two ends of the member. No direct external load on this member. If you found these two conditions, the member can be called two-force member. What is the meaning? What is the advantage? Why you are lucky if you found this type of member? If you can find this type of member, I can do the following. Here is member AB. I have nothing with this member. At connection A, we have pin support. So we have two reactions, YA and XA. If you have two-force member, I can remove this member. I can delete it and put only one reaction or in the same direction for this member. One more time. If you have two-force member and you are sure that this member is two-force member, please remove it, delete it, and put only one reaction in the same direction of this member. That's it. So this problem is converted to this simple problem. One more time. For this problem, for example, this member, I found that this member is 2/4 member. What should I do? The horizontal member will be the same. I'm gonna delete this 2/4 member, and I will put only one reaction like this. If you have connection like this, and I discovered that this member is 2/4 member for the two conditions, 2-pin connection at the two ends, no direct external load, so this member will be 2/4 member. What should I do? Okay, the horizontal member will be the same. I'm gonna delete this member and put only one reaction, R. Remember, your reaction must be in the same direction of the member. In this case, your member is vertical, your reaction is vertical. Your reaction must be in the same direction of the member. So this member is inclined like this, your reaction will be in the same direction. In our problem, your member looks like this. That means the reaction will be in the same direction like this member. Please make sure your member is 2/4 member. How can I figure out that this member is 2/4 member? We have two conditions. This member has two ends, and the two ends are 2-pin connection. No direct external load on this member. That means this member can be called 2/4 member or link member. I can remove it and put only one reaction. Any question for this point? Do you have any question related to this point? If you have any question, go ahead and ask what you want. Okay, so we have equivalent here. How much? Guys, we have something, few things in this course cannot be accepted. Probably can be accepted in engineering mechanics, but today cannot be accepted. Like this one. What is the equivalent for this distributed load? How much? So the equivalent load, the distributed load value is 10 kilonewton per meter. The total length is 4 meters. So the equivalent will be 4 times 10, 40. Not accepted for any student in this course who can put this value wrong. The value of the distributed load times the total length, you can give you the equivalent. The second thing, we have inclined force. We cannot do anything with inclined force. We need to figure out the horizontal component and vertical component for this reaction. Remember, it's given this angle 45. So this angle will be 45. So this component will be r cosine 45. This component will be r sine 45. We have three equilibrium equations. Summation f of x equals 0. Please write everything in x direction. We have positive xa. We have negative r cosine 45 degree. Do you have anything else? No. Equals 0. First equation. I cannot solve. Second equilibrium equation. Summation f of y equals 0. What do you have in y direction? Please list everything in y direction. We have positive ya. We have negative 40. We have positive r sine 45 degree. Nothing else. Equals 0. Second equilibrium equation I cannot solve because I have two unknowns, ya and r. Guys, do you remember the third equilibrium equation? Yes. Summation moment at any point equals 0. I highly recommend to take moment at support with the highest number of reactions. Support A has two reactions, so I'm going to take moment at A. I'm going to assume clockwise direction is positive. Do you remember, guys? Moment equal force time distance. One of you send me an email regarding moment in hydrology and hydraulic homework. Guys, we don't care about two different courses, hydrology or structure analysis. We are looking for moment. Okay, you are looking for moment. Do you have force? Yes. Do you have distance? Yes. Multiply your force by distance to get a moment. That's it. So, do you remember we have a very important condition for the force and the distance? Force and the distance must be perpendicular. Be careful. Anyway, taking a moment at A, so xa times 0. xa times 0. ya times 0. We don't have distance between ya and the point A, xa and the point A. 40 times what distance? What is the distance between 40 and the point A? Do you know how much? The distance? First, 40 and the distance are perpendicular. The distance will be 2 meters because the total distance is 4, so half distance will be 2. What else? R sine 45 degree negative, opposite direction. Time what distance? What is the distance between this component and the point A? What is the horizontal distance? 4. What else? R cosine 45 degree. I need someone to give me an answer. What is the distance between this component R cosine 45 degree and the point A? What is the distance between this component R cosine 45 degree and the point A? Any answer? What is the distance here? Thank you, Benjamin. Thank you, Jennifer. Yes. Your force is horizontal. That means I'm looking for vertical distance. Vertical distance between this point and this point, point A. We don't have vertical distance in between, so your distance will be 0. It's a fatal mistake. It's wrong. It's wrong. If you have a force at this point and you are looking for moment at this point. So this force will be multiplied by 0 to get a moment at this point A. Why? Because your force is horizontal. That means I'm looking for vertical distance. Do you have vertical distance between this location and this location? No, we don't have vertical distance. So your distance is 0. Be careful. So this term will be cancelled, this term will be cancelled, this term will be cancelled. The only unknown in this equation is R. So 40 times 2 divide 4 times sine 45 degree R equal 28.28 kilonewton. If you put R here, 28.28, I can figure out the value of XA. XA will be 20. If you put R here, 28.28, I can get YA equal 20 also. So this problem became easy because I figured out what is the type of this member. Two-force member. Two-force member, we have two ends are pin connection. No direct external load on this member, so I can delete it and put only one reaction in the same direction of this member. Any question? Guys, do you have any comment, any question so far? For the homework, any question, any comment? Guys, keep in your mind, what is the main purpose or what is the required from homeworks and the quizzes? Any answer? Why I'm giving you homeworks and giving you quizzes? Do you know why? I'm telling my kids about this point. You are doing homework to do mistakes, and then you are learning from these mistakes. Then in the exam, you are good. So probably you submitted your homework. It's not excellent. It's not good. It's not perfect. But right now we learn it. What is the mistake? What are the mistakes we did? Okay. For the quiz I forward to you, we need to learn. Probably you need to rewatch the recorded video to solve the quizzes. Then you are learning. All of this stuff will help you to solve good in the exam. Yeah, practice, yes. Yeah, practice for the exam. The new topic It's not a new topic. It's we are continue to analyze beams and frames. Just a review. We have three types of support. The first one called fixed. We have three reactions. Vertical reaction as a force, horizontal reaction as a force, and moment. We have hinge or pin support. We have two reactions. One vertical reaction as a force, one horizontal reaction as a force. The third support called roller support. We have only one reaction. Do you remember what was the direction of this reaction? It's not vertical or horizontal. This reaction is perpendicular to this piece of the roller. How can we figure out these reactions? We have three equilibrium equations. Summation of all forces in x equals 0, summation of all forces in y equals 0, summation moment at any point equals 0. Guys, please remember, your moment equal a force time distance. Your force and your distance must be perpendicular. Be careful about this point. We have different types of structures. We have external forces. These external forces will create internal forces. The internal forces can be axial force or shear force or bending moment. And these internal forces will be used to calculate stresses or will be used next semester or next year to design your structure. We will have another two courses, concrete design and steel design. Actually, we will use these diagrams or these internal forces to design the building, whatever the type of this building. So this course will be considered basics for the next year. Okay? As I told you, the internal forces in beams and the frames, the subject for this chapter, we have three internal forces. The first one called axial force. The second one called shear force. The third one called bending moment. Let's focus on the first one. Axial force. Sometimes we can call it normal force. Axial force is a force parallel to the member. Parallel. Your member is horizontal. The force is parallel to this member. Sometimes this force is pure compression, or sometimes it's tension. Compression, this force pushing the member. Tension, pulling the member. If the force pushing, it's compression, it's negative. If the force pulling, it's tension, which is positive. So we learned two concepts here. The force will be considered to make or to cause axial force, or sometimes called normal force, if this force parallel to the member. If this force pushing, it will cause compression, which is negative. If this force pulling the member, so it's a tension and will be positive. Let's watch this video.
Last time wouldn't that be damaging? I don't know. We have everything. That's safety cord, you know? Yeah, it's negative.
We have a vertical member. This vertical member under the effect of tension force. Can you watch what's going on with this member? This member is under tension.
We have everything. That's safety cord, you know? Yeah, it's negative.
Can you watch what's going on here? Neck deformation. And then fracture. One more. Video for compression. This column under the effect of compression. This head trying to push this vertical column. One more time. So, sometimes your member or the member in a building can be under the effect of compression, like this, or sometimes this member under the effect of tension, like this. Both of them, the force parallel to the member. Sometimes this force pushing, sometimes this force pulling. Any question? Any question? Okay, looks good. The second internal force called shear force. This one is very important. Please pay attention. If you have a part of the member, like this part, and we have two opposite forces, one coming down and the other one going up. This force which is coming down will try to get this part of the member down, and the other force which going up will try to get this part up. So we can expect something here called shear of the member. So to have a shear force, we have force perpendicular to the member. Wow, this is the first difference. To have an axial force, your force must be parallel. To have a shear force, the force must be perpendicular to the member. And these two forces or these forces are opposite. We must have opposite forces, one coming up and one coming down, to expect this shear. So shearing force are an aligned force pushing one part of a body in one specific direction and another part of the body in the opposite direction. The shear force is the force in the member acting perpendicular. So guys, please pay attention. Which forces cause axial force? The force parallel to the member. If the force pushing, it's compression. If the force pulling the member, it's tension. Which forces causing shear? The forces perpendicular to the member, and these forces must be opposite to each other to make shear. Let us watch this interesting video. It's very interesting. Pay attention to this video. To understand this video, I would like to explain something for you first. Guys, this beam is supported here and supported here. We have roller and we have roller. At this point, we have concentrated load P. At this point, we have another concentrated load P. So guys, if you have forces like B and B, we have here reaction and we have here reaction. That makes sense? So at this location, we have shear because this force P would like to push this part down. And for this reaction would like to push this part up. So at this location, we can expect shear. Go ahead and watch the video and see what's going on. Please pay attention what's going on. Can you watch? shearing. We have shearing. One more time. One more time. We have one concentrated load here, and we have reaction at this support. So we have two opposite forces, and the two forces are perpendicular to this beam. One of them would like to push the beam down, and the other one would like to push the beam up. So we expect shearing in between. So this failure in this beam happened due to shearing, because we have two opposite forces perpendicular to the member. Any question? Any question? Did you get it? Okay. So the first internal forces, as I mentioned, called axial force. The second internal force is called shear force. The third internal force is called bending moment. When I have a moment, can you answer this question? When you have a moment, if you have a force and you have distance, and the force and the moment and the force and the distance are perpendicular, that means we have a moment. So for any building, any structure, any member, you have a force, you have distance, both of them are perpendicular, then you have a moment. The moment will cause this member to bend. You have deformation like this. You have a force, this force will cause reaction. This reaction time distance will make moment. This moment will cause this member to bend. I'm sorry, to bend. Can you watch this video? So we have a beam. This beam is supported by this support on the left and this support on the right. And we have one concentrated load at midpoint. Can you watch? Bending, deformation of the beam. What's going on? This force will cause reaction. So we have a reaction, we have a force, and we have horizontal distance. If you multiply the force and the distance, you have a moment. This moment caused this deformation. So guys, to summarize what I said, keep in your mind, we have three internal forces. I cannot watch them in any building. Internal forces are created inside any member. These internal forces can be axial force, shear force, bending moment. The axial force is a force must be parallel to the member. Sometimes it's pushing, sometimes it's pulling, based on its tension or compression. The second one called shear force. These forces must be perpendicular. to the member. We should have two opposite forces to cause shear. The third internal force is called moment, bending moment. If you have a force and you have ligable distance, the force and the distance are perpendicular, that means we should have a moment. This moment will cause deformation for the member. So keep in your mind, any structure around you at this moment, you have to expect internal forces. I cannot watch them, but they are there. Axial force, shear force, and bending moment. Can you watch this building? You are standing at this position. Your weight is vertical and downward. My question is, your weight will cause axial force in which members? Can you watch this building? We have column and we have beams. Can you tell me? I need answer right now. Can you tell me your weight or the weight of this person, which is vertically downward, will cause axial force in which member? In the columns or in the beams? Any answer? Guys, are you still here? We have a person standing on this slab. This person has a weight. The weight of any person is vertically downward. This force or this weight will cause axial force in which part of the building? In the columns or in the beams? Thank you, Jennifer. Columns. For one reason. This vertical direction or this vertical weight parallel to what? The vertical direction is parallel to columns. Parallel to columns. So this weight will cause axial force in columns. The second question, the weight of this person will cause shear in which part of this building? This weight will cause shear in which part of this building? Columns or beams? What do you think? Thank you. Beams. Why? Why beams? For one reason. This vertical weight is perpendicular to this direction of the beams. So if your force is perpendicular to the member, will cause shear. If your force parallel to the member, will cause axial force. If this force has a distance, will cause moment. So right now, you are standing in your building. Believe me, you are causing axial force in one part and the shearing force in another part and the bending moment probably in both of them. One more question. If you have horizontal force, do you know how can we get horizontal force? From wind. If you have wind load, we can expect horizontal load on this building. Can you tell me this horizontal force, which is coming from wind, will cause axial force in which part? And the shear force in which part? What do you think? If you have horizontal load, I believe this horizontal load is parallel to this beam. So we have axial in beams. And this horizontal load is perpendicular to this vertical column. So we have shear. So if you have wind coming to your building, we can expect axial force in beams and the shear force on columns. So we don't need to remember all of this stuff. We need to remember only one thing. One thing. Keep it in your mind. If the force perpendicular to the member, we have shear. If the force parallel to the member, we have axial. If the force has a distance, we have moment. That's it. Keep in your mind, we have three internal forces: axial force, shear force, and bending moment. How can I figure out which one causing axial, which one causing shear, which one causing moment? You have the cases.